Okay, good morning everyone. I thought I would give a quick overview of the finished prototype. Well, as finished as a prototype can ever obviously get. So this is the completed WSPR beacon prototype board. So I thought I'd just quickly go over the various components of the project, sort of in the flesh, as opposed to, just writing them up. And then I'm going to try and get some screen capture or some video of the display itself. So at the moment, the situation is that it's been flashed from fresh, so it's powered up completely from fresh and hasn't been configured in any way. Okay, so I'll just go over the various components. I think most of them are fairly obvious, but it might be interesting for somebody. So here I'm pointing with my trusty pencil. This is the main control board. As I say, these boards, I tend to pick these up, these prototyping cards, I don't know, from eBay or from wherever. They're just a nice way of getting a PIC-based project off the ground, because they've got everything on board. You've got a power supply. So in this particular case, I've got a 5 volt and a 3.3 volt power supply. The 5 volt regulator has got a heatsink bolted to it because it's supplying quite a lot of power on the board. And I did find that without the heatsink it was close to thermal shutdown, so which is, I'm not quite sure how hot that is, probably around about 70 degrees. It's fine with the heatsink. It should have a heatsink anyway. I'm not using the 3.3 volt supply, so that's essentially just open circuit. So power's coming in here. I'm currently supplying, let me see, about just under 14 volts. So I mean, that's quite a lot of drop for the regulator anyway, 14 down to 5, which is hence why it's getting so hot. You can also supply power via this this power connector over here. There's a little switch on the side for turning this little board on and off. We've got a USB connector here, which I'm not currently using. There's a couple of little switches, which is nice touch on the board. This switch, the lower switch isn't being used. The upper switch is the sort of transmit standalone transmit enable button. It's also used to put the device into bootloader mode on power up. There's a little push button here, a little recess push button. That's the reset switch. This is the PIC 18F25K22, which is my sort of, I don't know, people tend to have favorite devices. I quite like this device. It's fast in that it runs at 64 meg from an internal clock, no external crystal required, hence the empty space here. I hope you can see all this. It's a little bit difficult to tell on the camera. I'll have to go and have a look in a minute when I've finished. A couple of reverse polarity protection diodes, one for the 3.3, one for the 5 volt supply, power light. What else is there on here? Few capacitors and decoupling and smoothing and bits and bobs, usual stuff. And say the PIC with all its headers available. This set of headers here is the pin header for the PIC Programmer. I personally use a PIC Kit 3. I've never had any problems with it. It's been brilliant. I don't tend to use a lot of embedded or ICE in circuit emulation or anything like that. I generally use for debugging. I tend to connect a serial interface to the PIC and then use trusty sort of printf statements or to print debug information over a serial interface. I find that a lot easier to use than in circuit emulation. Okay, what else have we got on this board? I've tried to pack as much on this board as possible. Obviously ran out of room quite quickly. Here is the kind of very cool little GPS module that I picked up for, I think it was under £5. I can't remember the exact figure. It was under £5 off of eBay. It's currently connected to an external antenna. I'm in my workshop at the moment, and the antenna is a magnetic antenna. It's kind of like magnetically clipped to the side of the workshop. So it's got it can see the sky, which kind of helps. I think you can probably just about see there's an orange flashing light here underneath the GPS module. That's the 1 pulse per second tick. There's a little LED on the board. The main guts of the board are on the underside with the LED. This on the top of the GPS is its passive antenna, which sort of came with the module, so you can either use that or the external antenna, whichever you like. My workshop's got a metal roof, so which is why I'm using the external GPS, because my Whisper beacon design won't transmit unless it's got GPS lock. Okay, what else have we got here? This little module here, these are very, very cool. I like these a lot. What was it called again? Hang on a minute. APC 220, sorry about that. APC 220 module. It's a obviously all this is written up in the blurb. It's a radio serial interface. That's essentially what it is. You can run it, I think, up to 19200 over the air. I think you can run the physical interface at 56k, something like that. But it gives you a relatively high-speed serial link over the air, which obviously this is all things radio, and we must do things over the air whenever possible. Why use a cable when you can use the air? So I like these little modules. You can drop them in. The board can stay standalone, connect up power. You can squirt debug back to the control software, or you know, it's you sort of plug and play, plug it in, open the serial port, forget about it. That simple, really. They don't seem to have any particular funnies. They work just as well as a bit of wire, really. Not obviously as fast as a bit of wire, but you know, most projects don't need ridiculously high rates. Okay, so that's that. Here's the sort of, I suppose, after the PIC, the core of the project, which is the AD9850 direct digital synthesis module. Very nice little module. I'm only using the sinusoidal output, obviously, for this particular project. There's the device itself. They do consume quite a lot of power. I seem to remember it's about 300 milliwatts. Hence why my voltage regulator was getting a little bit hot without the heat, before I added the heatsink. That's its 125 megahertz reference oscillator, which, as I've pointed out, I think on another video, is the source of potential output inaccuracy, which is why I've added calibration into the software. Manual calibration to allow you to offset the frequency of the output of this module to compensate for the fact that this is probably woefully inaccurate. Well, certainly mine's inaccurate. I don't imagine if you bought half a dozen they'd all be inaccurate in a slightly different way. Okay, so that's cool. So right, so the RF from the direct digital synthesis modules coming out of here. So out of here is the is your your final frequency, band base frequency, 7 meg, 14 meg, whatever. So that is output on a little cable to the PA module. This is a very cool little PA. I picked these up on eBay for about 10 quid. Obviously it only does, they say a couple of watts, 3 watts, depends on where you buy it. I'm getting about 33 dBm out of it, so something like that. A couple of watts around about there, depends on the band. I mean, this is Whisper, so it's not that power dependent. You're not trying to kick out tons of power. You're good on half 500 milliwatts. So in fact, you don't want to push too much power in this mode anyway. So these little modules are great for that. Maybe it could do with a little bit more power, but future work. So this is the power to the module. This little arrangement here is the power switch. I've gone for a solid state power switch for the PA. So I've got a little P-channel FET configured as a high side switch, driven from an opto-isolator. So the PIC running at 5 volts is optically isolated from the 12 volt rail or 13 volt rail, which is used to run the power amplifier. Always a good idea Don't want to lose a pin on the PIC. Right, or the whole PIC. So output of the PA through a bit of unfortunately not a very tidy bit of interconnect here, but that was all I had lying about. So this is now coming out at transmit power of 32 dBm or whatever into the QRP labs output filter stage. Now I could have built all this. In fact, you have to build the filters anyway. They come as a kit. It all comes as a kit, as a matter of fact. I could have laid this out, but to be honest, for the money, there wasn't much in it. You've got PCBs, you've got relays, everything's there, and it was sort of, I don't know, $25 or something for the whole lot. For the time I had available, it really wasn't worth me sort of reinventing the wheel. The only thing I've done slightly differently with this module, with the relay switch module, is that in the original design, the highest frequency module goes at the end, and then you put subsequent lower frequency modules down the stack, and no matter what band you're running in, the highest frequency module is always in circuit. So if you had, say, about 20, I've got 20 meters and 40 meters in the original layout, they would both be in circuit. Now I've modified the board slightly. I just want, that's a good idea. I'm not saying it's not a good idea, it is. I just wanted to run each band completely separately without running them all through the 20 meter one at the end, or the highest frequency one at the end. So I've modified this switch slightly so that when I switch in these filters, they switch in individually, and they're not chained with the final high frequency output stage, if that makes sense. What else we got there? Oh, obviously the LCD display. This might be the tricky bit to try and capture this on camera. It's not looking great on the screen. The contrast of the display seems to... I might have to take another little video with my phone or something to get a better idea what's going on with this display. At the moment, it's just dashes. It's dashes across here, dashes hertz, and then that's the time running at the bottom here. So if you can't see this, sorry, I'll try and get another video of it in a minute. That's the time which is being sourced from the GPS module, and it's the same time that's being reported on the software on the laptop. I've got a laptop sitting here out of shot, kind of over there, which has got the Whisper control panel software that I've written to control all of this, and it's displaying the same time echoed back to the PC over this link here, over this radio link. Cool. Got a bunch of LEDs down here, one per band, just to indicate which one of these bands is currently switched in. Obviously they're all off at the moment. There's an LED on the PA module somewhere around sort of here, I think there it is, which comes on when the PA is transmitting. Clearly it's off at the moment. Oh, this chip down here, probably not completely necessary. I'm just, all this is a 7-channel Darlington driver device. God, I can't remember the name of the number now. Hang on, 2 ticks. ULN 2020003A. Yeah, sorry. So it's like 7 little Darlington drivers. So I'm using those to drive the relays. I probably could have driven them directly from the PIC, but maybe not such a good idea. These also have reverse polarity protection, not reverse polarity, back EMF protection diodes built in. This board comes with back EMF diodes built in, so it's like, I didn't technically need to fit those because they're already included in this chip. So the PIC is driving the relays via this driver chip, rather than directly, whatever. Generally, I think it's good practice. So there we go. Okay, I'll stop this little bit of the video now and then make another extension to this as I get it to do things. Thanks for watching.